Good morning, good afternoon, good evening, whenever and wherever you are. My name is Anna Rochelle, and today we're going to talk about exponent rules. And we're not just going to talk about exponent rules like that we talk about on the middle school level, but we're also going to talk about them as we move further into Algebra 1 and Algebra 2. So normally I forget one all the time, so I just figured I'd put them all up and then we can go through each of the exponent rules, and then we'll do some of the problems that you would normally see on an Algebra 2 level. So the very first rule that we talk about is the product of powers. So a product of powers means I have a product where I have the same base, different exponents. So what happens with that is I'm going to end up keeping the same exact base, and I'm just going to add the exponents. So what I'm going to end up doing is, in this particular case, I'm going to end up with x to the sixth power. The reason why we add them is because technically this is saying like I'm multiplying two sets of numbers. And I have four x's in here. Whoops. Four x's in here that I'm multiplying, right? And then two more in here that I'm multiplying. So technically I can see that I have six x's in total, and that's kind of like where my answer is going to be, right? And then I can absolutely apply this to fractions as well. So what'll happen with a fraction is I'm going to create common denominators, right? So if this was like, x to the 1/4 times x to the 1/2, I would need to create common denominators between the 1/4 and the 1/2, right? So I would have 1/4 and 2/4. And then I would end up with x to the 3/4 power in that particular case. For now, we're going to leave it in fraction format, but we will talk about later in the video how that looks in with a radical. Okay, a power to a power is basically saying I have two things that I'm multiplying, because this 2 is kind of like my placeholder for things that I'm multiplying. And I have x to the third in each of them, right? So realistically, I can say that I have x to the sixth power because I know when I multiply the same base with different exponents or same exponents, doesn't matter which kind of exponents, I would end up with 6 of them. Just like in here, I would add those exponents. So we're kind of building on this last concept. The other way that you can solve this problem is you can take x to the third times 2, or whatever these two numbers are, you would multiply those two exponents to get your final answer, in this case, x to the sixth power. Now, when we look at a power of a product, we're looking at, and I don't like to use the word distribution because you're not really distributing anything, but you're applying, maybe, application, this exponent to each of the exponents that are in here. In this particular case, we only have x to the first, y to the first. So now, since we're applying that, we're going to go ahead and apply that 4 to the first, sorry, x to the first times 4, y to the first times 4 as well. And so I'm going to end up with x to the fourth, y to the fourth. Now, in this particular case, sometimes we don't necessarily just have x to the first, y to the first. Sometimes we'll have like, 3x squared y. And let's say that's to the fourth as well. I'm going to figure out that I have a 1 here, that invisible 1 as an exponent, same invisible 1 in here for the y. So I'm going to end up having 3 to the fourth power because I'm going to do 1 times 4. And then x is going to be 2 times 4. So I'm going to end up with 8, and then y to the fourth as well. Now, in most cases, teachers will say that you actually have to do that math, 3 to the fourth. So you're going to want to know that it's 81 x to the eighth, y to the fourth as a final answer in here. Okay. With quotient of powers, I wanted to discuss two similar types of problems. So the first type of problem that we're going to talk about is what happens when I have 6 in the 6 as an exponent in the numerator, 4 as an exponent in the denominator. So similarly to when we had the multiplication piece, we just added the exponents, right? Because multiplication is just repeated addition. And so since division is just repeated subtraction, we're going to do the same business. We're going to actually take this x to the 6 minus 4 power and say that I have x to the second power. Because what this is saying is I have 6 of these x's up top, and then I have 4 down below. And so all I'm doing is canceling out the ones that are similar and seeing that I have 2 left over in the numerator, right? The difference with this one versus that one is that in here, it seems like I have more x's, more variables in the denominator. And because I have more variables in the denominator, what's going to happen is my x is going to end up in the denominator. So normally I would just take the exponents and subtract them, and I'm going to be left with x to the negative second power. Now, I want to bring you over to here a little bit really quickly because that's kind of the same thing, and want to talk to you about these negative exponents. We don't want to have negative exponents. They're kind of like taboo in the math world. Like, you really shouldn't be dividing by 0. You really shouldn't be having negative exponents. There are certain things that mathematicians don't like, and these two things happen to be one of those. This happens to be one of those things. So in this particular case, I'm going to end up having 4 x's in the numerator, right? And then 6 in the denominator. So what happens is when I cross out the ones that are the same, I'm going to end up with 2 in the denominator. Now, technically speaking, there's this invisible 1 that I'm multiplying by in the numerator, right? Because 1 times anything is anything. So I'm going to end up with 1 over x squared. And that's how we really change this negative exponent to make sure we have a positive exponent. So same business here. I know that in order to make my exponent positive, I'm going to do x to the second, but I'm going to put it from the numerator to the denominator. And if it happens to be in the denominator, I'm just going to go ahead and make it positive and bring it into the numerator. Now, it'll get a little tricky when you have multiple versions of these. There is a video that you can see that I did one large problem that encompasses a lot of these things. I'll probably link it in the description below so that you guys can see what that is. Okay, so if you need some more assistance on trying a problem, definitely go ahead and check that video out, and then we'll move forward with this now. Okay, so the power of a quotient, when we look at the power of a quotient, what we are looking at is we're kind of taking, again, this 3 right here and really kind of distributing, but not really distributing, maybe applying might be a better word, to all of the exponents in here. So I'm going to change this around. I'm going to say that this is the first power and this is the second power. And what I'm going to end up doing is I'm going to use this power of a power principle and apply it to this power of a quotient. So what's going to happen in here is I'm going to have x to the first power times 3 over y to the second power times 3. And I'm going to end up with x to the third, y to the sixth as my final answer. So all I'm doing is distributing, but I really don't like to use those words because you're not really distributing. Distributive property is a little bit different. So maybe applying, okay? And then anything to the 0 power is 1. One of the things I do want to mention with this case, with this 0 power, shows up frequently in Algebra 2 when we have, I think they're called rational equations, rational functions, or maybe even some other types of functions. I forget which functions they are. They show up a lot where there's, lots of math going on in this type of equation, and it's all in parentheses and it's to the 0 power. So a lot of students tend to say like, oh my goodness, this is a really challenging problem. And what they don't notice is they don't notice that the whole thing is to the 0 power. And then all of a sudden they're like, oh no, I did all this work and it's all to the 0 power and I didn't have to. And it tends to show up on a test as like a test of are you really paying attention to what you're seeing, what you're doing, things like that. So just be aware of that. Make sure that you are paying attention to what is where, and you notice that anything to the 0 power is always going to be 1. Okay, so now we have a product property of radicals. So in this particular case, this is where we start off with algebra 2. So anytime we have something to an exponent, and the exponent is a fraction, okay? So for example, if I have 100 to the 1/2 power, that is the same thing as 100 to the square root power. So this 2, actually, I'm going to erase this right here. And we're going to change it up a little. So I'm going to have 1 over, let's say 2. So this 2 is going to go in here in this, like what I like to call nowadays a root nook. And the first power will either apply in here under the radical, or you can end up with root 100 to the first power, okay? In either case, you're going to have your answer of 10 anyway. So what you're looking at is you're looking at the root, okay? So let's say, for example, I changed and I said I have, let's say, 32 to the 2/4 power. I don't know, I made this up as I went along. Hopefully this will come out clean, but we'll see. So I'm going to end up with the 4th root of 32 because the denominator is always going to be in this little root nook that I have right here. And then I'm going to go ahead and I'm going to square that. So when I want the 4th root of 32, that means I want 4 of the same exact number that multiply to get 32. Now, I don't know of one that is exactly correct. So instead of doing this, not exactly correct, but like that comes out to be an integer. Instead, what I'm going to do is I'm going to extend this a little bit, put this 32 to the 2nd power. And then go in and find the 4th root of that. So I know that 32 times 32 is going to be the 2nd power, right? And then I know that 32 is going to be 4 times 8. And then I know that 8 is going to be 4 times 2. And so now what I see is I see that I have 1, 2, 3, 4 fours, which is exactly what I want. I want a number that repeats itself so many times so that I can pull it out of the radical, right? So I'm going to end up with 4 outside of that radical. And then because these two they only repeat twice instead of 4 times, I'm going to end up with the 2 in the radical. And my root nook, this 4, is still going to stay in here, okay? So that's what I have when I'm talking about the product property of radicals. One of the things that I wanted to make sure that I state very clearly is whatever numbers are in this radical are actually the same thing. So for example, when I have, let's say I have, sorry, 100x to the 4th, y to the 3rd, and then this whole thing is to the 1/2 power. That 1/2 can either get distributed, right? Or we can put it all into a radical of that. Okay, so everything is going to apply. This 1/2 is going to apply to all of my exponents, all of my different terms within that set of parentheses. Okay. Now, when I look at quotient property of radicals, it's almost the same thing with the exception of now instead of having multiplication, right? Because product is multiplication, I'm now going to end up with quotient. And so let's say I have, for example, 80 over 5. And each one of these has this, fourth root, right? So technically, because both of these guys have the fourth root of each of them, I can take this really big fourth root of 80 over 5. And what I know is that actually 5 goes into 80 16 times. So now I'm really looking just for the fourth root of 16. And then I'm gonna say like, okay, well, which number multiplies itself 4 times to get to 16? In this case, I know that it's 2, but this is gonna come with time as you move through like just more practice with these kinds of numbers, you'll see that they just start to come naturally. If you need additional assistance, don't hesitate to reach out to me, either make a comment on this video or go ahead and email me, or I will definitely respond to you so that you can have a little bit of a better practice with these numbers. And so since I found a group of 4 things that are exactly the same and I'm looking for the fourth root, I know that my answer to that problem is going to be 2, right? Same business if this would have been 80 over 5 and this was all to the 1/4 power. These two things actually mean the same exact thing. Technically, I would have done 16, right, to the to the 1/4 power, because 80 divided by 5 is 16 already. Okay, so we're going to go ahead and we're going to try some problems. There are 6 problems in here, 2 that already have these radicals, sorry, 3 that already have these radicals, and then 3 that don't. And so the instructions are, we're just going to use properties of rational exponents and radicals to simplify the expressions, okay? Again, we always want positive exponents. We never want negative exponents. And we're gonna go ahead and work this stuff out. Okay, so anytime I have an exponent to an exponent, I'm gonna multiply that out. So this is gonna be 9 to the 2/3 power, which we know the denominator is gonna go inside of this little root nook. And then I'm gonna have 9 to the 2nd power is 81. And then 81, the 3rd root of 81, I don't think it's a thing. So I'm going to just say that we are looking at the 3rd root of 81. Sometimes teachers will be totally fine accepting this. Sometimes teachers will be totally fine accepting this. It just depends on, or sometimes you might even need to go a little bit further and break this apart so that you have, for example, 3 and then the cube root of 3 as a final answer. I would just pay attention to what your teacher says and then what your teacher does in the class so that you can go ahead and give the final answer. Okay, so this 6 is like 6 to the 1st power, so I'm going to have really 4 over 4, right? Subtracting 1 over 4. So this is 6 to the 3/4 power, or the 4th root of 6 to the 3rd power, or even further. So you want to make sure, again, double check with your teacher, how far do you want to take these problems? So this one is a fancy one, and I do want to take a look at this one together. So if you've already started this and you're like, I'm a little confused, let's walk through this. My recommendation would be to take all of these numbers actually are to the 2/3 power, right? So what I'm going to do is I'm going to kind of remove the exponent first from all of these and put the whole fraction to the 2/3 power. So like undistributing, factoring out, kind of unapplying, and applying to the fraction as a whole. And then I know I can simplify the 4 and the 16 to make it 4. So then I would end up with 8 to the 2/3 power or the cube root of 8 squared. That would be it. Honestly, you can definitely go in, put into the calculator, put into the calculator 2 to the 2/3 power, 16 to the 2/3 power. But what I find mostly is students don't pay attention to, not students, teachers don't really like using calculators. And students usually don't know right away in this early on in the chapter how to use the calculator appropriately for fractional exponents. So I would leave it as is. In most cases, either of those two answers would be just fine. Okay, so the same thing happens when I have this, x to the fourth, x to the second. What I'm going to do is I'm just going to add up my exponents and call it good. In this particular case, I know that I have the fourth root of these two things. So really what I'm looking for is I'm looking for applying this fourth root to each of these terms, right? So in this case, I have 6 to the 1/4 power and 8 to the 1/4 power. So I can technically say I have 6 times 8 to the 1/4 power, right? Or I can simply recognize that these are both fourth powers, so I can just multiply these two within that radical, right? So then I'm looking for the fourth root of 48, which is, we're looking at 16 times 3. And then 16 we talked about, we know is 2. So we're going to have 2 and the fourth root of 3 as a final answer. Or we can have 48 to the 1/4 as a final answer, or root 48, fourth root of 48 as a final answer. One of these three should be correct depending on what your teacher has a desire for. Okay, so in this case, because I see that they're both fifth root, I can right away take this and divide it by 2. So I'm going to end up with 243. And then the fifth root of 243, if I'm not mistaken, is actually 3. Yeah, because 3 times 3 is 9, and then 9 times 2 more 9, 2 more 3s is 81, and then 81 times 3 is 243. So 3 is final answer. Same thing in here as this number 3. These are all to the third root. So I can take 6 times 72 over 2, and then go in and take the third root of all of that. 2 and 6 can simplify to 3, and then 3 is 216, and then the third root of that is actually 6. So again, we want to maybe take a look at having you memorize some of the perfect squares, cubes, fourth power, fifth powers. They do come up pretty often. So I think it would be super helpful for that. And I will see you in another video. Bye.